Hello, math fans. All right, so we're going to get going here with the next lesson in probability. This is section 5.3 in the textbook, even though it says lesson 7 on these notes. That's just incorrect. Don't worry about this. So it's on page 313 that we'll be working with today. All right, so what we're doing today is now we're taking probability and we are using some of the counting methods you would have learned in chapter 4 of the textbook, and we're applying those to now. We're going to get into some more complicated problems, so to count out what you want over what the total is. We're going to start dealing with bigger percentages, and we'll need to make sure we have those counting methods that you guys mastered last section down for this part here. Otherwise, you could be in trouble. All right, so for example, let's look at this first one here. Jamal, Ethan, and Alberto are competing with 7 other boys to be on their school's cross-country team. Ooh, look at that. All the boys have an equal chance of winning the trial race. Determine the probability that Jamal, Ethan, and Alberta place first, second, and third in the race in any order. Okay, so any order is kind of a key there when we're dealing with counting. Order doesn't matter. And let's take note. The greatest school sport of all time, cross country, has been mentioned there as well. That's important. Not really, but it's still fun. All right, so we know that we're dealing with something where the order of the outcome matters, right? Winning a race, first, second, third. When you're dealing with counting things where order matters, you're dealing with NPR or permutations. Okay, so for this part here, let's start with finding out what we want. J, E, and Alberto, these 3 guys coming in first, second, and third in any order. Okay, so what that means is we have 3 people in total, and we have 3 possible outcomes for them, right? It would be different if we wanted Jamal to come in first, Alberto second, and Ethan last. Then it's already kind of predetermined. But because we're dealing with these 3, and they can go in any arrangement they want, any permutation, we need to solve this with 3p3. Okay, so that's our want. Now we need the total. So our total is how many racers do we have running all together? Right? 9 racers. And there's 3 possible winners. So NP3. These are total outcomes for everybody now, okay? So these are the 3 possible ways, or the 9 possible ways that 3 positions could be picked. So now you use your calculator to use the NPR button, and you go 3p3, and then you're going to go 9p3. 3p3, for those of you keeping track at home, is 6. Oh, wait a minute. 7 other boys. There's 7 runners. That should be a 10. All right, sorry about that. 10p3. All right, 10p3. You plunge that into your calculator, and that's going to be 720. Okay? So now you can divide those both by 6 to take out a number, or you could just give it to me as a percentage, and you should get 0.83% or 0.0083. Okay. Now, when you're dealing with big counting questions like this, when you're dealing with like 10p3, 6p, or 3p3, you're going to get smaller percentages. Okay, and that's all right. Don't be afraid of that. Totally possible for them. Okay. All right, next question. A husband and wife meet a group of people and explain how they had 3 other children at home. Had 3 children at home. Determine the probability that at least one of the children is a boy. Okay, so we want to find the probability of least one boy. Okay. So we need to count out all the different ways that you could have one boy out of 3 children. Okay. So for this one, I'm going to go back and I'm going to count the total ways you can have children first. Okay. So for your total, this is our denominator. You got 3 children. And for each choice, you got a boy and a girl. 2, 2. All right. So that means if you're having 3 children, you have 2 times 2 times 2 possible outcomes, which is 8. Okay. 8 possibilities there. So now what you need to do is count out the ways you could have 2 boys, or sorry, 1 boy. So you could write them all out. So you could have 3 boys, and you could have 2, or you could have 1, right? Now, unfortunately, when having boys, the order doesn't matter. It didn't say what is the probability of having a boy first and then having all girls. It said anything, any boy. So you could have this combination here, and then you could move the boy into the middle, and the girl could be, the girl could be in the middle, and you could have the boys on both ends, or you could have the boy first and 2 girls, or you could have 2 girls and a boy, or you could have a girl, then a boy and a boy. So there's a lot of different combinations there. So it gets a little complicated. So what you can do is you can calculate how many different ways can you have no boys. So that'd be girl, girl, girl. There's only one way not to have any boys, right? So there's one way where you have all girls, you have no boys. And we already know that the total amount of outcomes that we would have is 8. So if there's 8 different ways to have 3 kids, and we know there's one way to have no boys at all, then that means there must be 8 take away 1 equals 7 ways to have at least one boy. Okay, 7 ways to have at least one boy. It's that at least thing. At least means 1 or more. So it could be 2 or 3. So sometimes in those cases, it makes more sense to actually calculate the ways to have none of them and subtract that from your total. And then that gives you the answer. So the probability of at least one boy, so P equals 1, at least one B, that would be 7 over 8. Pow. Or if you want, 0.88. Okay, or 0.875. I don't mind. I usually just like 2 digits, as my answer. So if I have 0.875, I just write it as 0.88. Or if I have like 0.0000987, I would just write it as 0.0099. Okay? All right, next one. You have 12 tiles that spell out the words Saskatchewan. All right, so you're playing like Scrabble with your grandma or something like that. If you guys know what Scrabble is, I don't even know if kids play board games anymore. I don't know. Is there a TikTok channel for Scrabble? Either way, doesn't matter. You have 12 tiles that spell out the word Saskatchewan. You place the tiles upside down, mix them around, and rearrange them in a row. Determine the probability that when you flip the tiles back over, you will spell the word Saskatchewan again. Okay? So we want the probability. I'm just going to put SASC to save me some time. All right. So now we got to count out the total first, right? This is going to be want over total. So now you're counting here, but you're counting identical objects. All right, the S's are the same and the A's are the same. So if you remember how to count that for your total, you have 12 letters in total. So you count out 12 letters, would just be 12 factorial. But because you have identical or repeating objects, you have to divide that by the number of repeating objects to their factorial as well. So we have 3 A's and you have 2 S's, like so. Okay, so you're just going to work that out. So 12 factorial divided by 2 factorial times 3 factorial works out to be 39,916,800 different ways that you could rearrange the letters to Saskatchewan to spell something different, right? Quite a bit. Quite a bit. Now, how many ways can you spell the word Saskatchewan with the letters that spell Saskatchewan? What you want? Well, guess what? There's only one way to do that. It's to have them in this exact order. So your total number, or the number of ways that this outcome happens that you want, is only one. Okay? So your answer for the probability to sell Saskatchewan is just 1 over 39,916,800. Leave your answer like this. Don't write out some ridiculously small fraction. This is fine. Okay, you can't simplify that fraction because 1's a prime number. Hopefully you know that. And you're good to go. All right. A woman here, last example, is spinning. There are 18 bikes in a spinning class. They are arranged in rows of 3 with 6 bikes in each row. 6 friends take the spin class. 4 of them are women and 2 of them are men. They want to be in the same row, but cannot request which bikes they will use. Determine the probability that the 6 friends will be in the same row with the 2 men on each end. Okay, so what that means is I'm going to draw this out. You don't have to draw this out, but you have 3 rows of bikes, right? Here's one row, another row, another row, okay? And there's 6 spots. Like this, right? For each one. 1, 2, 3. The squares and the X's aren't anything different. I just figured out while doing this that writing X's instead of squares would have been easier. So what you want to do is you want your friends, you want them in one of these rows all together. They don't want to be apart. So either row 1, row 2, or row 3. Okay? Because they're the 6 best friends clubs and they want to be together. So, all you got to do is kind of figure out what's going on here. Okay, so you're laying them out. Your order here kind of matters. So this is going to be a permutations question. So you're going to use NPR. Now, we're going to do probability of big F. Big F stands for friendship. Okay? So the probability of our friends here being together. I'm going to solve for the total first. Okay? I'm going to do the permutation on the bottom piece first and then walk you through this. So there's 18 bikes and we're arranging all 18 of them. Okay? So it's 18p18. All right? So that's going to be a really big number. Next, we have to figure out how we're going to arrange the men. And now, the men and the women. Now, what's great is the men want to be on the ends. All right? Like this. And the women are going to ride in the middle. It doesn't matter which order they're in there, but this part here does matter, kind of like where they go. So let's deal with the men first. There's two guys, and we want them to go. There's two, and we're choosing two. And then what we'll do is we got to count the ladies and where they're going to sit. So there's 4 of them, and we're choosing all 4 of them. Now, if you look, okay, cool. We've used up like this entire row of seats, but we still have 12 seats left over for other people that we need to account for that will be used, and 12 people will use those. Now, if you look here, this is more of a complicated one. This is where you're doing probabilities with permutations or combinations. When you're using this stuff, do a quick check. If you look, take all the numbers, all the n's on top that are in front of the p, so 2, 4, and 12. If you add them up, they'll add up to this n on the bottom. And same with the r's, or the second number that goes in the formula. If you add up all those numbers, they work out to be the same. Okay? And that's a nice little check that you can do with this stuff. Full disclosure, this stuff gets difficult because you've got to be able to determine between a combination of permutation or identical objects and then solve probability. So you need to make sure you understand chapter 4 before you get into this stuff. We'll spend quite a bit of time on this next little bit. This tends to be some of the hardest stuff in the course. So if it seems hard and confusing at first, don't worry. We practice it. We're going to be here a while. You'll get used to it. Now, we're almost done here. We figured out where our 6 friends are going to go, but there's one catch. They could go in this first row here, or they can sit here, or they could sit at the back row, depending on where they get. It didn't stipulate where in the rows they wanted to sit, just one of the rows. So there's 3 choices there. So what we have to do is we take all of this and we times that by 3 as well. Okay? Now, if you take your calculator, try all this stuff and make sure you understand it. If I work out the top, it comes out to 144. And if I do the bottom, it works out to 13,366,080. Now these are even numbers. You could write it as a decimal. You could leave it like this, or you could step up to the plate and simplify that fraction. It's really not that hard. You just use your calculator, and you're going to get 1 over 92,882. So there's a very small likelihood that not only will they be sitting together, but the guys will be sitting on either end. All right. So now for your assignment today, on page 321. Hey, 321. That's 1, 2, 3 backwards. Let's go 4. Four to 10, and then 12 16. For some of these, hopefully you guys know deck of cards. Right, there's 4 suits. You got clubs, spades, those are black cards. And then you got hearts and diamonds, which are red. Each suit has 13 cards. You know, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, ace. And in total, there are 52 cards. We'll work on this quite a bit, but that's your lesson for today.